Hey everybody, my name is Chris Noring. I work at Microsoft as a cloud advocate. You can reach me on Twitter at Chris_Noring. I'm here tonight to talk about Blazor, this new framework from Microsoft, and the fact that you now can use C# everywhere. The first thing you need to know when it comes to Blazor is that it has different hosting models. That means that you can choose one of two paths of how to build your application. The two different paths are, first off, the client-side one, and secondly, the one that is server-side based. So what is the difference? Well, in the client-side version, it runs in the browser as WebAssembly application. That means that anything that runs in a browser is part of a sandbox, so it can't do anything to the client's computer, which means that there are things that you can't do, such as access the file system, but you can use .NET Core standard libraries, definitely. The server-side model is a bit different because it's part of an ASP.NET Core application. So let's try to look at some pros and cons for these two different models so you are better informed of what you can do. When it comes to the pros of this, it means that it doesn't, for the client, it means that it doesn't have a server-side dependency. It just works as a standalone application written in WebAssembly because that's the end result. And this means that you can deploy it on GitHub or Azure or wherever you want. It's just a web application. It also offloads the server. That means that the client, per definition, is taking on a lot more work. There's a lot more application logic that goes on. The cons is that you are restricted by the browser. The capabilities that the browser can perform is what you can perform. And you also need the browser to be fairly modern. It needs to support WebAssembly. The size is also a thing, because when you start using .NET libraries as part of your application, some of these needs to be yanked out and bundled together with your application logic. So the bundle is a little bit bigger than the server-side version. And there's also some limitation on the .NET runtime, and the tooling support up until now is a bit less mature. But the differences between the two hosting models is becoming less and less. What about the server-side version? Why should I consider that? Well, if we look at the pros, we see that the size of the application itself is way smaller because it's piggybacking on top of a .NET Core application that you're running anyway. Also, the tooling and debugging is more mature, which means that you can take advantage of existing debugging, for example, and you think of it more as a full stack application. So if you have a breakpoint in your data layer, you can have that and easily move on to the Blazor application in one go. It can use the full .NET, any .NET Core compatible APIs, but there are cons. So the cons for the server-side model is latency, because every interaction that you do is a network call. There's also no sense of an offline. If there's no internet, you don't have a Blazor application. Whereas if you were to use the WebAssembly version of this, you could, for example, with the notions of progressive web apps, implement some kind of offline features, but you can't do that here. Scalability is another con because there's only so many clients that it can support, because there's a lot of client connections. It's a big chapter of how this works, so I'm not gonna bother you too much in a 20-minute talk about Blazor, but we have some docs that really covers this part. Now, how do we build a Blazor application? Well, it's .NET Core, right? And if you built any applications before in .NET Core, you know that you have an executable called .NET and the new keyword. Once you have the new, you're supposed to select some kind of template for your project. If you're running the latest and greatest .NET Core, one of these templates is called Blazor WASM or Blazor WebAssembly, if you read it out. And you just call that, and if you want to call the -o flag, you can decide what the name of the directory should be. And then you call .NET build followed by .NET run, and this pretty thing is what you end up with, this application with a menu and a main area. Now there are development tools, the three good options. Visual Studio itself, Visual Studio for Windows, it has a full support, it has the project template, it has syntax highlighting and a debugger. Secondly, there is Visual Studio Code. It's a great editor for many things. The Blazor support in it has the project template, it has a debugger, but it doesn't quite have the syntax highlighting of the Razor template that you actually used to author components. So I'm not really sure where they're at, but last time I checked, there was some discrepancy. Thirdly, and lastly, we have Visual Studio for Mac that almost came out of nowhere and just added this really sweet Blazor support, which supports the project template, syntax highlighting, and a debugger. So I would say that Visual Studio for Mac is on par with Visual Studio for Windows, like it should be. And I will also show you some demos here in Visual Studio for Mac so you can see for yourself how good that is. Now, these kind of frameworks, especially the WebAssembly one that I'm showing you here, are usually called SPA frameworks, single page applications, and those are component centric. They consist of small dedicated pieces of reusable code. Blazor is no different. Here's what a component looks like. You intermix HTML with C#. It's a Razor template, so if you've used ASP.NET before, this is not news to you. Looking here on the right side, we see that we have the markup file that consists of different directives like page and code. And at the top, we have the notion of markup and some interpolation of variables. And in the bottom part, we see that we have this code section where we have variables and methods. And we can also see on line 8 here how we hook up a method towards a click event. So markup part with interpolation, the code behind, if you will. With this said, I know that they're working on a alternative where you could actually have the markup in one file and the code behind completely in another file. There are some people who want that. I'm not sure whether this has landed yet or not, but I know that that's being worked on. Component input. This is one of the most important principles when it comes to all kind of component interaction. The idea is that you pass data from top to bottom. So component input is about exposing properties on a component that a parent or a component higher up can set. Looking here at the right, that we see that we have parameters. We have this square bracket parameter, which means that this title here is publicly exposable. It's not private like everything else. And you can set this from the outside. Looking at the bottom, we see that we have a parent component that uses this, in this case, a product detail component, and it sets the title property to a string. And we have another property here in which it sets this description with a value as well. So that's a fairly simple example of a component input. It doesn't get much more complicated when you try to give it an entire object either. Now, the other side of the coin is component output, because it goes in the other direction. If data was flowing from top to bottom, output or events flows from bottom to top. And the reason is that you usually have a few smart components that sits on the data, that sits on the logic, but the majority of your components are dumb or presentational components, which is just very good at showing your data, but not much more. So what you do is that you provide event callbacks in your dumber components that raises events when something happens, like a user does a selection or they push a button. At that point, you raise an event and say, this custom event with this payload data has happened and someone needs to care. So here on the left, we see that we have a click event in a child component, and we also see that we have an event callback that calls invoke async with some kind of payload, in this case a title. And in the parent component, this ends up being captured. So the parent component says, if this click event occurs, I need to care because someone has changed this component for me. And my clicked function is called in response to this child doing something. So here you have the chance to maybe call a backend service and say, hey, this component, this product changed, and you need to persist that in a database, for example. Now I'll show you how you can be building a utility component with parameters and routes. Okay, I've opened up a Blazor project in Visual Studio for Code. I'm about to create a component. I give it a name, test.razor. You probably want to give it a better name than I am. I clear up some code here, and one of the first things I do is to specify a page directive. This is how you would route to this component. You don't have to have this. This is only if you want it to be part of that route in the URL in your browser. Now I also give it a code section, and I start typing my markup, and I give it a div, and I'll keep working on this in just a few seconds. But meanwhile, I'm creating this variable that I want to show in my markup. I give it the parameter decorator. Remember, this is how I made something public. And yeah, it's mad at me for a reason. I can't expose a primitive, a string towards the outside world. It needs to be a property. So I clean this up. I instead use this prop syntax to give me a property. I call it public string, and I give it a name title. I'm really inventive here, right? So I give it a name title and a getter and a setter, and I'm able to interpolate this inside of the markup portion of my page. So I type title. Now I have my component, it's done, and I can go to a parent component and start using this. So I navigate to my parent component. First off, I clean up some stuff that doesn't need to be there, and I type the name of my component, which is test. And I start using this property that we call title. So I type title. It's helping me with auto-completion. I give it a string as input. So this is me passing input from a parent component towards a child component. We will show this in the browser and show that it works. So we start the debugger, and it starts building, and hopefully in a few seconds we'll have a browser that's up and running. All right, building, and there it is. Now routing in Blazor is about 4 major things. Should it be routable? If a component should be routable, it should have a page directive and a route. If it shouldn't, don't add it. It's also about route parameters. Part of your route can have wildcards, values that you don't know what it is beforehand, but you know, it could be the ID of a product, for example. And also query parameters. That's the last part of routing, and we need to care about those as well. Looking here at our bottom bullet, we see that we use those to kind of limit how much data comes back from the backend. And this is a very important topic, because if you don't manage this in a good way, you might end up getting millions of records back, and nobody's happy about that, because it's going to take you all day long to load that page. Now, route parameters look like this. You have a route and a param, and the Blazor is able to kind of interpret what this means. And in the case of the other route here, we can see that we are able to set a type to as well if we wanted to. And looking at our page directive, we see now that we have a route param in the form of ID, and we tell it explicitly to become an integer. We can also see here in our code section that we have a public int ID with a getter and a setter, and it's able to dig this out. So the only thing we need to do is to create this ID variable just like the page directive on top. And once we have this lifecycle method down below here on parameter set, we know that this value has been filled in by the routing mechanism, and we are ready to go towards the backend and say, hey, given this ID, give me the product that this corresponds to. Right. When we are talking about navigation, there are 2 different ways of doing that. One is to use nav links. These are just anchor tags that you're used to from HTMLs that are wrapped into Blazor components. And the other way is the programmatic navigation, in which we tell some kind of navigation manager to say that, hey, as the result of doing this operation, could be saving a product, we want to navigate back to a list page, for example. So 2 ways. Navlink, this is you clicking a link. The programmatic way is to call the navigate to method on the navigation manager. And lastly, remember to call the lifecycle method or define it inside of your component on parameter set. This is when your value is ready to use. So the navlink, the navigate method with the programmatic way of doing things. And let's talk about query parameters again. As I said, this is about how to slice the data. This is to ensure you don't get 2 million records back, but in this case, only 20 records. Query parameters are everything that happens after the question mark in your URL. In this case, we have a page that says, I want results from page 1, and I want to make sure that the page size is 20 records, so that's clear. This is not a package that's being added to Blazor from the beginning, but you need to add it. If you've used ASP.NET before, you know that this is a package that you need to be adding through the command line or via your Visual Studio. But remember to add it, and once you have that, you have the capability of parsing the query part of your URL. So here you see how we are using this query helpers class and a method called parse query. And once we have a URI, we're able to say, hey, I want to try to yank out a certain page param, or I want to yank out the page size. And lastly, I end up going towards some kind of data repository and say, given this page with this page size, give me this slice of data. Let's show this in a demo as well, so you can see how you could be using query parameters. So hopefully you understand how this works. Okay, so we have opened up our application. We will try to work with some concept of routing. We have a list of products. We are looping those out. We have a navlink and an href. And we also have the parsing here of different query parameters. And we see that we have our URI. We also parse out page and page size from the query part of our URL. And we try to assign that to param and param2. I should probably rename param and param2 to something more valuable. But the point is we assign them to page param and page size param. And lastly here on line 32, after we've parsed the second one, we see that we send that into get products, both of these parsed params, and yeah, it ends up slicing the data for us. Now this is an in-memory database. The get products has some reasonable defaults, but we're saying if we pass them, let's use some link query statement here and get the correct page for us and the right number of records. We will take this and show this in the browser how this can work, so you understand what's going on. And yeah, we have the route kittens because we like kittens. Okay, so we go into our URL and we start typing kittens. We get all the kittens. We just want a few, as many as we can handle. So we start by saying page. We want page 2. And from page 2, we want a certain page size. We want 2 kittens on from page 2. So we get the third and the fourth kitten. We change into page 1, and we see that we get the 2 first kittens. So we can definitely see how the query parameters are working for us to slice the size of the data. We are nearing the end of our talk, but I just wanted to mention that Blazor helps you with forms. It does so by implementing this edit form component, and yeah, you'd probably have to look at a longer version of this talk to get all the details, but know that it helps you with collecting the data. There are dedicated controls to handle different kinds of data. It also helps you with validation summary, so if you've been using ASP.NET Core, this is not news to you. There is a default behavior there. I think I'm showing, yes. So here you have an annotations class, and you can definitely assign that as a model, and you get some free validation because of it. And that could be anything. It could be required or matching some kind of regular expression, or if you've seen data annotations before in .NET, you know how this works. And we rely on a lot of the defaults here from the annotations that we add to the class. And yeah, we also have dedicated components to handle various types of input. We can also trigger validation from code should we want to. In this case, we need to work with a more advanced context object. So instead of a model, we talk to a context, and we can call validate on that context, and this is how we programmatically are able to validate. Normally, it validates by you hitting a submit button. There's also some custom validation. What we do in a custom validation is to build our own validation class completely. This is if you want to add validation to your class and you're not happy with whatever validation you have on your annotated class. So yeah, I'm not going to go through this in detail, but I'm going to show it if you want to pause here in the video of this talk, so you can study this in detail. And yeah, does a lot of things for you, and you can definitely start using this custom validation thing that adds rules. And we're not going to show a demo of this, we don't have time. There's also a notion of JavaScript interop, which means that you can make JavaScript and C# play nicely together, which is great. And you again need to inject something, in this case an IGS runtime, and which enables you to call various JavaScript functions like so, and you're able to deal with the results. So this is a perfect mix if you do have some investments or libraries in JavaScript yet you definitely want to use, so you can mix the two. In summary, Blazor has two hosting models, part of either you can be part of an ASP.NET project or it's a standalone WebAssembly. The WebAssembly is in a sandbox. Regardless of hosting model, you can use .NET libraries and C# in all the layers. There is VS for Mac that I showed you the demos in. There's VS for Windows, and you got syntax highlighting, debugging, and a project template. VS Code is almost as good. It doesn't have the syntax highlighting, but other than that, it's a perfectly good low-cost option. Thank you so much for listening, and I hope I will see you on the internet somewhere. And definitely send me IMs if you got any questions or queries about this talk.